We all know that both the processors, CPU, and the GPUs of the graphics cards are made using transistors, but what is a transistor? Developed by John Bardeen, Walter Brattain, and William Shockley at Bell Labs on December 23 of 1947, transistors actually mean transfer resistance for their properties. It is an electrical element made with semiconductors that is capable of altering the flow of current to allow it to pass or not, representing the ones and zeros of the binary systems. Transistors are, in a sense, the heart of the processor, since they are responsible for performing processing tasks at very basic level and are the ones that in sum determine the work capacity of a CPU. Since computers work in a binary system, these on and off states of the transistors serve to represent the ones and zeros of the binary system. A transistor can be defined in a simple way as a switch. In fact, it is the element that allows qualifying a processor as semiconductor, since they can adopt different states based on letting the current pass through them or not. Well, this is allow us to establish a general rule that indicates that the more transistors, the more gross power a processor can have. But since they are elements that work with electricity, they generate heat and have to meet specific characteristics to function properly. Historically, transistors were flat components that are printed in one way or another on a silicon plate by chemical reactions. Their size were standard and were always reduced by a factor of 0.7 each generation. Starting from 19 nm, they went to 56 nm, then 45, 32, 22, etc., until reaching 5 nm, which is currently the smallest size in manufacture. This progression is due to a self-fulfilling prophecy by the industry, Moore's law, because if each year the size of the transistor is reduced by a factor of 0.7, every 2 years the size of the transistors is reduced by half. The problem comes to 2010, when a new transistors architecture began to be marketed, FinFET. It is a type of transistor that allows to considerably increase the density and energy efficiency, but makes it difficult to maintain a standard measurement, not to mention the complexity of sustaining an arbitrary progression when the sizes are becoming so tiny. So don't be swayed by the marketing of the jeje of a commercial CPU or the nanometers of its transistors, because they are only individual factors that influence the final performance of a processor.